Good evening. Next, symmetrical pi-type attenuator. Symmetrical pi-type attenuator. Don't mind spelling mistakes. I know the spellings, but I'm writing very fast. See here, this is a circuit diagram. The series arm is R1 and shunt arm is this is R2. This is R2. Here, this is perfectly terminated with its terminated impedance, which is R0. And this one is, see, if it is perfectly terminated, this input impedance is also R0. This is the series and shunt arm of attenuator can be specified. The series arm, R1 is a series arm and R2 is shunt arm. These two can be represented in terms of Z0 and gamma propagation constants, the characteristic impedance and propagation constant. See, as we know, this symmetrical pi-type attenuator is as it is a resistive network. Therefore, Z0 is only Z0 is equal to R0. And propagation, as we know that a propagation constant is alpha plus j beta, where alpha is attenuation constant, beta is phase shift constant. You know that beta is responsible for phase changes, but we don't have any inductor and capacitors. So therefore, the beta of this particular circuit, attenuator circuit, is 0. So therefore, propagation constant is only alpha, attenuation constant. Attenuation constant. So design of attenuator consists of finding values of R1 and R2. So we have to calculate an R1, R2 values. So here we have to remember two important formulas. Those are R1. Don't think about the derivation for this R1 formula, and remember this formula. So the R1 in terms of trigonometric hyperbolic functions. This is sine h alpha, where R2 is equal to R0 cot h alpha by 2. These two are important. So you need to remember these two. Remember these two values. Then, as we know that this sine alpha can be written like this, an exponential. So therefore R1 is equal to R0 into the sine alpha can be written as e power alpha minus e power minus alpha by 2. Okay, this further it can be written like this. This is e power alpha. Okay, further see here, by definition of propagation constant, the propagation constant E or gamma, by definition of propagation constant, by definition propagation constant, this is natural logarithm of output input current Is divided by output current IR attenuators. So R over R, and this can be written as here, this can be written as e power gamma can be written as Is by IR. Or we know that e power gamma is alpha only for attenuator circuit. So therefore e power alpha is equal to Is divided by IR, which is same as N, where N is the attenuation constant. Attenuation constant. So from this R1, so R1 is equal to R0 into e power alpha can be written as N n minus e power minus alpha can be written as 1 by n by 2. So therefore e power minus alpha can be written as 1 by e power alpha. So therefore 1 by e power alpha can be written as 1 by n. So therefore this R1 is equal to R naught into, if I take LCM, this is n square minus 1 divided by 2n. So this is the formula for R1 shunt. This is series of phi type attenuator in terms of R naught and attenuation constant in, or this is in terms of alpha propagation constant only. Propagation constant, we should know that a propagation constant of attenuator is only alpha. Why? Because it is a resistive network. There is no any uh, phase responsible components like inductor and capacitor. So therefore, definitely beta is equal to 0, and alpha is only, propagation constant is only attenuation constant. Similarly, let me stop first. Similarly, R2 is equal to R naught into cot h alpha by 2 can be written as sin by cos ante it is tan. So cos h alpha by 2 divided by sin h alpha by 2. This can be written as R naught into cos h alpha e power alpha by 2 plus e power minus alpha by 2 divided by 2. Similarly, sin h alpha can be written as e power alpha by 2 minus e power minus alpha by 2 divided by 2. Now here this 2 and 2 get cancelled here. So therefore R2 is equal to R naught into this e power alpha by 2 plus 1 by e power alpha by e power minus alpha by 2 can be written as 1 by e power alpha by 2 divided by e power alpha by 2 minus 1 by e power alpha by 2. If I take LCM, this becomes R naught into e power alpha by 2 into e power alpha by 2. So this becomes e power alpha plus 1 divided by LCM is e power alpha by 2. And whole divided by, again this is e power alpha by 2 into e power alpha by 2. This is e power alpha minus 1 divided by e power alpha by 2. And this e power alpha by 2, e power alpha by 2 get cancelled. This is R naught into e power alpha plus e power alpha minus 1. So from this e power alpha can be written as n. So therefore R2 is equal to R naught into e power alpha is n plus 1 divided by n minus 1. This is another formula for shunt term of phi type attenuator in terms of R naught and attenuation constant n. Like this, see, for in symmetrical phi type attenuators, just we have to uh, remember these two formulas, R1 and R2, and don't think for how this particular R naught into sin h alpha came, and just you need to remember these two. If possible, I will explain in class later in next semester or else like that. So I'll completely derive the total circuit total formula for this. Otherwise, I'll send another video regarding this after examinations. First, you need to remember this. You know this diagram of pi type attenuator, and this pi type attenuators. So series of and shunt terms can be represented in terms of Z0 and gamma. The Z0 is it is resistive network only, so therefore it becomes R0. And gamma is alpha plus z beta. There is no any L and C components, so therefore the beta factor will be 0. So attenuation constant of any attenuator is only alpha, which is propagation constant of any attenuator is only alpha. So therefore, once you know this is the mathematical formula for sin h alpha h gamma. This one e power alpha minus e power minus alpha by 2. Whereas cos h gamma, cos h alpha can be written as e power alpha plus e power minus alpha by 2. This is a hyperbolic trigonometric hyperbolic function definitions. These definitions. One is cot h alpha by 2. This is sin h alpha. Thank you.